All right, well, welcome. Today, this is the 9:30 session. This is Winston 1C. We're going to be talking today about use of mobile data collection in large-scale UAS operations in the U.S. Virgin Islands disaster relief areas. And we're going to have speaking with us Will Nanny. Matthew Nanny and Will Rumley. I tried to do it by memory, and I couldn't remember two names, so pardon me, guys, from AECOM, and I'm going to turn it over to you guys.
Thank you.
Thanks.
Hi, so I'm Matt Nanny with AECOM. I'm the UAS manager and mobile technology lead. This is Will. He is our also UAS pilot and the Mobile GIS Enterprise Systems Administrator for that. So he's in charge of the AGOL. So first, let's talk a little bit about the project, what the purpose, scope, how and why, and how that changed over time midway through the project. I got a call on a Thursday evening to come down. They said that as part of a relief effort, we need to be down by the next Thursday, mobilize full force to be able to start mapping the roofs of, at that time, 200 to 300 houses. We weren't sure, hey, get down here, we're going to figure it out while we're down here. Oh, by the way, bring everything you need ahead of time before you get down here because it's not reliable here and there's like Kmart available to buy things. So I'll go into that a little bit here as far as scaling up for that project. But what the purpose of this was is we're there to support the larger FEMA effort. There's money there to rebuild the roofs. Over the last year, nothing has happened. It's been a year since the hurricane and the roofs are still tarped. Holes in the roofs, complete structures were demolished. And we're there to help map that, redesign the roofs for architectural purposes, as well as for re-engineering the roofs to fix them, not just patch them, fix them for the future for that. And we're using UAS technology to be able to do that. Each house got about $30,000 for that money for roof redesign, whatever damages to repairs that need to happen for that. This project was supposed to take place late August through October 27th. So I was happy because I would be home in time for Halloween. It is still ongoing. So it kind of snowballed there for that. So like I said, the original scope was between August and October for 200 to 300 houses. In reality, to date, we've surveyed 838 homes, 331 of which are in St. Thomas, 500 in St. Croix, and 7 in St. John's. And you see, that's weird. Right there for that, that was one of the worst ones there. I pulled that for some of the UAS imagery that we took for that. And someone lives there, frankly. He was a nice guy. He came out and talked to us, says, when are you going to fix my roof? I said, I'm sorry, sir. We're just here to map your roof. He's like, I don't have a roof. And I'm aware of that, sir, and I'm so sorry. So we tried to exercise a lot of cultural sensitivity while we were down there. But in general, everyone was very pleasant, very understanding, and happy that we were there. So kind of jumped ahead a little bit earlier. We had 7 days. We had 2 Phantom 4 Pro drones. I went and acquired 12 additional batteries and spent about $4,000 worth on Amazon in the short time that we had there for that. Just get all the necessary accessories, weather gear, things of that nature that we would need for that. It's a very interesting place. Rain is constant, 17 to 20 mile per hour winds. How many of you guys out here are a UAS pilot? All right. There were scary, scary conditions out there. A Phantom 4 Pro can take wonderful imagery with 20 mile an hour winds. I didn't think it. I was skeptical when we got down there, but it's 100% true. We did burn out 2 gimbals and had to replace those units, but they can handle it, so put a lot of wear and tear on the machines itself. And it's, like I said earlier, we did use Phantom 4 Pros and iPhone 6s with LTE. We'll get into the software side here in just a second. So we had a few choices, softwares. That was the number one thing that I had already kind of previously analyzed Drone Deploy, Pix4D, Maps Made Easy, a couple of the different applications there for that, but we needed something that had a cloud-based processing service to it. At the time, the scope of the project, the idea was that we were going to use photogrammetry on the back, and we're going to collect a bunch of data, and I'll get to that part here later in the presentation. We're going to process that data on the fly as we're going there, which I said, hang on a second. If we collect 200 images, it might take 4 hours to process a house on a dedicated machine, and we're collecting 20 houses a day. And said, yeah, everybody said, yeah, absolutely. And you're like, well, that math doesn't add up, but we'll get there in a second. We were still successful in that scenario. So we chose to go with Drone Deploy because of that. For data collection, the idea is that we would have cloud-based service to be able to upload the photos at the end of the day. We would be able to check for holes and go out and do reflies as necessary for that. We also use ArcGIS Collector, and that's integral to this process, to be able to manage the data, collect the data in the field, and also edit the data real time from the initial data collection, which took place in Fulcrum. Unfortunately, within those efforts, there wasn't a lot of training on the front part. We were not involved in this specific part of the task there for that on how to collect data in the field using an iPad. So they said, oh, great, I have an iPad, I have a cell phone, boom, here's my point, great, and I walk away. A lot of bad data. We walked up to a lot of abandoned lots to go fly the houses and realized there was nothing there. So there's a lot of confusion. So we were doing real-time data correction in the field as part of that. So safety. 100% we had to wear hard hats because we're in construction areas. How many of y'all that are pilots have flown with hard hats? It's not fun. I tripped over it 3 times while flying, but it's a health and safety concern. We eventually negotiated with them that the pilot in command at the time did not have to wear the hard hat because you're looking up. And the hard hat, as much as you crank it on the back of your head, it will fall off, and it's windy, as we established earlier. The other big concern, and this is going to come up over and over again for safety, is overhead electric power lines. And I'll go to the next slide here and kind of dive into that. So to take a step back, overhead electric power lines, they're everywhere. It prevented pre-flight planning from being an established thing. So we originally talked about the scope that we have one planner who plans out all the day's missions for today and the next day. Ahead of time, they send it out to the various people on their devices and they execute the tasks. What we found shortly is that that was not a good idea, and it was just as efficient to go and plan house by house using LTE in a connected state to be able to map the homes for that. Let me take a step back here. We'll talk a little bit about the airspace. That was my chief concern going down there. How are we going to get access to the airspace? We're in a TFR zone, and it's in Class C airspace. That was the easiest part of this entire project. We called the ATC. We said, hey, we're down here working with the FEMA effort there. And they said, oh, no problem. Just call us when you're done. That was it, and we were good. They said the only area of concern was, and we'll get to this in the next slide, there's a harbor area where there are seaplanes. And if the seaplanes see a UAV, they will ground immediately and call me and let me know that. So that we were dealing with seaplanes, not actual aircraft, not actually other manned aircraft other than seaplanes for that. As far as risks that we were running into, permanently parked cars. So these are when I say permanently parked cars that are still viable were damaged by the storms that people are waiting for insurance money to repair. So they're not abandoned cars. There was that in addition to that. There was also other hurricane activities, other weather systems coming through. Overhead power lines, I'm going to say it 3 more times by the end of this presentation. The topographic relief, and we'll get into some slides of that in a little bit later, and wildlife. They had a mini peregrine falcon that was indigenous to the island. We had a couple close calls, but no bird strikes. So to get in here, it's a little bit of the topography of St. Thomas specifically. You'll see down here where the icon is, there's a harbor area. That's where all the cruise ships come in. That's where all the seaplanes are for tourism activities. That was the hardest airspace to negotiate because we had to negotiate with the seaplane, say we'll be here between such and such hours. Thankfully, we'll see that from a density map later, there were not a lot of homes affected by there because it was protected by the cove. We started off in the area known as Tutu. It was a relatively high topographic relief area, 2 main ridges running through the middle of the island. You'll see here, flight operations and base of operations were actually at the Tutu Mall, the largest structure on the island itself. And so we were able to mobilize and deploy. A majority of the homes that were affected here in St. Thomas were in this area in Tutu. Okay, so question of why drone deploy? It became an estimate of economics. Did we want to pay for an enterprise license for $5K per user or $5K for the bulk of users? Or do we want to go with $129 a month? Because this is only a 2-month project. So we chose $129 a month. The end product, would have going with Pix4D been better? Yes, frankly. It produces a very high quality product, but it's not a hardcore photogrammetric tool, and that's not what we intended to use as, and we'll get into that a little bit later. So you're able to create a flight plan in the field. In this case, we were doing a literal shot call for real estate. It's a crosshatch pattern with 2 oblique periphery shots going around the edges at different altitudes to be able to create the 3-dimensional model that we needed. What we were looking for, and this is really distilled of the project, we're worried about the roofs, the lack thereof, the ability to fix the roofs, to improve upon the roofs for that, and that kind of becomes a central theme here. At the time, we were going to create these wonderful 3D models. We were going to do something in context capture and do all this great stuff, but the scope of what we needed to do was fix the roofs for that. And therefore, the pre-flight plans made sense to do in the field, and once again, overhead electric lines. So let's talk about the level of accuracy that we're getting out of that. 0.39 inch per pixel for ground sampling distance and an RMS of 13.44 centimeters. It's pretty good. That's just the Phantom 4 Pro by itself, no ground control. We did shoot ground control at the time, but we'll jump into that in just a second for that. So as far as the pre-flight planning and everything else, this is the central office we were working out of. We were working under the responsible charge of a surveyor qualified to work as a surveyor on the island, as well as an entire other survey crew working out there with RTK for that. On the right-hand side, you'll see Brad. He was setting a ground control point. Initially, we were having survey go ahead of us, but we were quickly leaping ahead of survey. Like I said, the way in which we deployed the UAS made it incredibly efficient to map all the homes, and we were well ahead of them. So what we needed to do is taking over the responsibility of setting some of the control points ahead of time. Survey was coming and taking building corners, and they were taking our control points 2 on the road as well, one for redundancy, one just for georeferencing for that. And when we got into that level of accuracy, I don't want to misquote, but it was fairly highly accurate once we got to there. But once again, absolute accuracy, not of a major concern. We're looking for high relative accuracy here. All right, so we talked about RTK and base station, and a couple areas there on the island there. That's Will's back, the ECOM logo, and that is the RTK station that we were using there. Of interest, originally we had idea if we're going to scope and use the GS80s and our LiDAR scanners by Leica to scan all the interiors of the homes. Too slow. We could do about 2 homes a day, and then we were wanting to cover hundreds within that time period, so we scrapped that portion of that project. But it would have made for very interesting results. So this is the data bottleneck. We have 838 homes. We scoped out how many hours it's going to take me to process that data. We estimate 4 to 5 hours per house, largely automated, on a dedicated VDI server with, I think there were 8 Tesla cards, which were equivalent to like some ungodly amount of gigabytes per card. The reality of that situation was if we tried to use PhotoScan or Metashape, which wasn't available at the time, would have been much better at this. But when using PhotoScan, you could run 5 simultaneous processes, but it did not expedite the processing time, even throwing the best available technology at that problem for that. So we resolved to use cloud processing and drone deploy. Part of our nightly process was to upload the photos. So we came to this conclusion 2 months later. I would love to say I foresaw this issue and talked about the entire time, but no one cared to pay attention until 2 months. We had that information available for reference and drone deploy. And we'll get into the mobile data side of the equation here in a little bit and just talked about how we were able to use that information. But one amazing thing drone deploy does is roof reports. Once again, high relative accuracy with the Phantom 4 Pros. We were able to export out exact dimensions within a margin of error is a little less than an inch on those. And you can see a sample, one of the roof reports there has all of the calculations, roof, slope, pitch, everything like that. This is a small sampling of that roof report. And we were able to use that for architectural redesign. So, you want me to switch over to you?
Yeah.
Cool.
Hey, so like Matt said, I was in charge of configuring and setting up our mobile data component. It arose partway after the project began because we showed up on the island. They had this data that was collected, not very accurate. We showed up at addresses, and like Matt said, it was like an empty lot. And so it kind of arose out of a necessity. So what we use is Collector. Who's used Collector in the room? Yeah, so pretty much everybody. Yeah, Collector is an awesome tool. I'm not going to evangelize it, but we like it. So anyway, so these are the specific reasons. So like I said, the addresses were really difficult to locate. Who's been to St. Thomas, Virgin Islands, U.S. Virgin Islands? Nobody? Okay, yeah. So if you've never been there, it's kind of, it is a U.S. territory, but it is a very impoverished, island. It doesn't get the same funding and the same credit that, mainland territories get. So the infrastructure is not the best. And so for that, the addresses are really hard to find. That's all I got to say about that. The initial data collection was inaccurate. The real-time tracking of project development was really important. Using Collector, we were out in the field, we were able to collect the data, and then, higher ups in the office who are managing the project could see, okay, this is the type of progress they're creating. We can see visually on a map, like, okay, they're working their way across the island. Good stuff. We had multiple teams out just because, like Matt said, there was like 838 homes and counting. So managing all of those flights was fairly difficult. So we needed a way to better organize ourselves before we went out in the field for the day, because all over the island, hard to communicate. There was a lot of data that was really important to be able to access on a whim. If you didn't know the name of the person whose house you were flying, if you weren't sure the exact coordinates, we could query that all in one thing instead of using paper. I'm a millennial, so I don't really know what that means. But a paperless workflow was really important. It was very windy, it was very rainy. So we started out with paper, did not work. A couple days later, this is what we came up with. So this is directly from Esri's website. And this is just an overview. If you use Collector, you're probably familiar with this workflow, but I'm just going to go over it just so it makes sense. So we had data. The data was just regular Excel sheets, just a bunch of coordinates collected from the different applicants, and they would give them our address, and we would geocode it and all that. We published services. In this case, we use hosted services in ArcGIS Online. It was safe. It was foolproof. We didn't have to set up any other infrastructure. Very easy. Authored a web map. Pretty much take your feature layer, throw it in a web map, save it, make it available to Collector, you're done. And then we chose to work online and not offline. We had a local data plan, so we had internet connectivity everywhere on the island. So when we made updates on the mobile device, immediately showed up, on a desktop back at home base. And so, like I said, there's Collector. That's the little logo right there. So this is just ArcGIS Online. I'm sure a lot of you have seen web maps just like this. I just wanted to show the simplicity of what it was, but it was an effective tool. So we have just our different feature layers, divided by island, and that helped us out a lot. And then what we would do is draw some polygons around houses that day that we were, looking to fly, and then divvy them up by teams. So this is in Collector. So another thing we had to really be cognizant about is our proximity to airports. If you've flown a drone before and you're Part 107 certified, you know that there are all kinds of regulations concerning your ability to fly in and around airports. And so what this is, we were able to just draw simple polygons, again, nothing too crazy, but enough where when we were out in the field, we could see, oh, wait, we're near the airport, even if we can't see it because it's on a mountain somewhere. So that was really helpful too. So you can kind of see in this one how close the houses were together. And so they're smaller homes, and there's not a lot of big plot size for a lot of them. So finding the addresses was hard. So what we could do is, before we went out that day, we could go into our feature layer and manually move points directly above houses, working with a local who knew the area, because we didn't. So something that was really important, especially for maintaining the project and making sure that everybody was on the same page, was access to this data. And for people who aren't GIS savvy, who maybe don't care to know GIS and just want pretty maps on a page, this is our solution for that. So this is just a simple web app builder application. We just made it AGOL. It's all hosted as well. And this application not only has the individual flight site locations, we also have the imagery that we took. So as the project went along, we were able to create this kind of mosaic image of everything that we've flown. So these are actually the aerials that were post-processed, and then we created services with that.
And that was a tile service directly from Drone Deploy.
Yeah, so Drone Deploy has a really great tool where it can create a WMTS service. So that's open source. And that tile service is easily pulled into web apps, what have you. So this was the most satisfying thing to watch. You know, you're out there, you're flying, you see all these bits and pieces, but to actually put it on one page and say, okay, you know, this is the island in its current state. This is really cool to see. And that's pretty much the mobile data component. It wasn't as difficult and complicated as it can be for a collector, but it was a useful tool to address a ton of different problems. So that's what we're all about.
And one addition to that, as we're wrapping up, is that we were collecting the data. We were collecting the data both for the UAS side of the equation as well as the mobile technology part of the equation. So we were charting how much time we were in the air, our battery usage, which aircraft were out there, which pilots were flying at the time, working in two-man teams for that. And so we were able to take the UAS and the paper tracking part of it, like you might use Kitty Hawk for, merge it in with what we're using Collector, and then bring that into a larger environment for project management as well. So that's the part of it I think we didn't know when we walked in the door what we'd be creating that we were particularly proud of for that. So we have a few minutes. Yeah. Okay. That's all. Do you have any questions? Ask me hard ones. Yes.
Not sure if it's hard. Okay. What about insurance?
Great. AECOM has an umbrella policy that's on the craft itself with full liability and collision, so to speak, for that. We did, like I said, we found that we burned out 2 gimbals within the first 3 months just because of those windy conditions and had to replace those drones for it. The cost of the technology versus the productivity we had was negligible. We had more invested in batteries at that point in time than we did in the drones themselves for that. Good question. Anybody else? Hey.
Was it difficult to get replacement parts or supplies to be given?
Yes and no. In the case of the 2 drones that needed to be replaced, we were able to go to Puerto Rico and purchase those, or someone got on a plane, flew to Puerto Rico one night, stay there, came back with the new drones to replace that. We were able to get some parts, extra controllers, things of that nature from Miami and have those shipped in there. You just can't rely on an Amazon because it takes a little longer for things to get down there. But it wasn't so rural that you couldn't get small bits and pieces, even down to, like I said, there was a Kmart. So you had access to things that you needed for that. Yeah. Cool. Anybody else? Please.
The data that you collected with the addresses, what is the local GIS
Scene
down there?
Yeah.
You know, are they able to capture that and add it to what they have, or are they not?
That's a great question. I'm trying to think how to navigate this to answer. The local government was helpful to a point. They knew their databases were not as clean as they needed to be. There was a lot of holes and gaps, and we found ourselves on the back end of the operation kind of building that information for them. So by the time we got to this point in the project, we had a pretty good database for that. We tried to give that back to the local government, and they, for whatever reason, decided to not take us up on that offer, even though we're basically giving them tons of free work. So it was interesting negotiating with the local governments there for that because pride got in the way, to be frank. Yeah, for that. Cool. Please.
You ever use OpenStreetMap or any of the data there? Utilities like overhead wires often show up on those maps depending on the density of the data.
Oh, no, that's a good point. It helped to a degree. We tried to do, like I said earlier, the pre-flight planning to go there for that and use other tools available. We had utility lines, electric lines, and overhead available to us as a GIS resource. We put those out into the map service initially, but you're out there. And one of the things, so you might have crisscrossing wires going here, and I say, okay, I can launch from that point right there and safely go up, above, and come back. And then someone will come and park a car. And you'd be like, oh, sir, do you mind? And we're flying, so we have one VO, one pilot. We're having to negotiate that. So we found that it was such a case-by-case basis that the pre-planning was almost not as useful. We knew topographic relief in certain areas, and that's something I didn't really stress much in this presentation. But the topographic relief, you might have a house that cuts into the side of the mountain. Say, well, how do you shoot that? It became a very interesting game for that. And I can say for myself and Will, like, we grew immensely as pilots during that course in time.
Yeah,
for that.
we dealt with a lot of updrafts.
Yes.
A lot of updrafts. And another thing, too, is on his point, the data that we did have access to begin the process, it was collected pre-hurricane, and everything changes. Power lines get knocked down, trees knock down power lines. Like you said, cars just are flying not flying everywhere. It's not a tornado. But, the state of the island is not as it was when the data was collected. And so there's obviously going to be some misnomers here and there. So, yeah.
Cool. Any other questions? Great. Well, thank you very much.